Hello everyone, welcome to my channel. In this video I'll be integrating a function which you can see on the screen, which is integral sine square x divided by cosine of x. So uh, let's get started. So the first thing I can see here is the sine square x can be written as 1 minus cos square x. So this becomes 1 minus cos square x divided by cos x dx. So I can write this as, I can split the terms, and it goes as follows. So if I split it, it goes 1 by cos x minus cos square x divided by cos x, and you have the dx right there. So now I can write 1 by cos x as secant x. You probably know that, I assume. And I can split the integral, right? So I can write this as two integrals. Now this becomes cos x, because cos and 1 get cancelled out, and we are left with this. So now I can write this as, integral secant x dx is, let's derive it actually. So but we know integral cos x dx is, let me write this like that. We know integral cos x dx is sin x, so I can write this as it is, and now we are left with this integral. So what we can do to solve this, so we can write integral secant x dx as, so let us assume f of x equals secant x plus tan x. So now we will be using this to integrate secant x. So if I multiply and divide by f of x, it just becomes secant square x plus secant x tan x. The reason I'm doing this is because the derivative of f of x is equal to this here. I can later replace this by f dash x. So we have divided by f of x, which is secant x plus tan x. So now this becomes integral f dash x divided by f of x. We already know this. This equals, don't forget the dx there. This is ln of f of x. Don't forget to put the mod there. So we replace f of x by the function we took, which is secant x plus tan x. So we got this. So our original integral is integral sine square x by cos x. So we write that. Now we have integral secant x plus tan x plus sin x. And don't actually forget the plus c there. We can further simplify this. Actually, we can write secant x as 1 by cos x, and tan x as sin x by cos x, and we have the sin x plus c. We can simplify this as, now if you take the common denominator, you have cos x at the bottom. On top you have 1 plus sin x. You have this outside, and now we can simplify this as, I can write 1 as sin square x by 2 plus cos square x by 2, because cos square theta plus sin square theta equals 1, and I'm left out with sin x. I can write this as 2 sin x by 2 into cos x by 2. I assume you know this identity already. Sin 2x equals 2 sin x cos x. I wrote that there, and now I'm left with cos x at the bottom. Okay, I'm just not writing this, I'll write this thing at the last. Now you have ln of, this can be written as sin x by 2 plus cos x by 2 whole square. And at the bottom we have cos x. So now the denominator can be written as on top we have sin x by 2 plus cos x by 2 whole squared, and we know the identity cos x equals cos square x by 2 minus sin square x by 2. So now what I can write here is the denominator stays the same, and in the denominator I can write this as cos x by 2 plus sin x by 2 multiply by cos x by 2 minus sin x by 2. So now here I can cancel out 1 cos x by 2 plus sin x by 2 here, and 1 in the numerator. So this basically becomes ln of cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2. So we can further simplify this as, if I divide by cos x by 2, we have 1 plus tan x by 2 by 1 minus tan x by 2. So now we know this formula. Oh, sorry. This can be written as ln of tan of pi by 4 plus x by 2. Because if I expand this, you get tan A plus tan B, which is tan pi by 4 is 1. 1 plus tan x by 2 divided by 1 minus tan A tan B, so it's 1 minus tan pi by 4 is 1, multiplied by tan x by 2. So we have the same expression in here. So the integral basically becomes, ln of tan of pi by 4 plus x by 2, and we have minus sine x plus c. So this would be the answer for that integral. You already seen that there. It was a minus, so this should be minus here. I'm sorry for that. So it was all minus all the way. Yeah. So this would be your answer for the integral sine square x by cos x dx.